you. Hello, everybody. I was going to walk around and be more exciting to watch, but this new design of the Macintosh has a beautiful curved edge that slides right over the lip that would cause my laptop to fall. So I'm just going to stand here to prevent that. So today, I am going to talk about simplicity. What I wanted to do was try and capture, well, why you should care about simplicity, what it means, what it is, and how to achieve it in Scala. So I wanted to start by talking about the why, and if I had to come up with one word to describe what we should try to do as programmers, that would be the word, right? So, I mean, it's not easy to come up with one word, but that would be my word. So, so anyway, there's a couple different reasons I think we should care. And one is that simplicity begets productivity. That's the begets operator. Essentially, we are paid to program, usually. And if, the more value we can create for the less value that comes in, and that part of that is less time, the more productive we are to society, right? So I think that what it really achieves, one thing that it achieves is economic. That, and it does it by if you make something simpler, if you spend time, which is money, today to make something simpler, then tomorrow, people who are using your code or your library can spend less time because they don't have to spend more time to figure it out, right? So that's how it's a way to make people more productive. So that's one way to think about it. And one of the things I wanted to say was that even though I think that's what I would describe, if I had to put it in one word, what we should try to achieve as programmers, I don't think we should always do it, because it really is an investment decision how much time to spend to make code better, because it is actually a bet that if I spend this money now or this time now to make this code better or make this design simpler, that in the future there'll be a payback. And if you spend 2 days to make something really beautiful and then no one ever uses it or no one ever needs to go and look at that again, then you actually made a bad bet. And it would have been better to just leave it complicated, right? So it's not a slam dunk that you should actually make code better or as good as you can. It's sort of like you have to figure out it's like investing money. If you have a limited resource and you have to sort of figure out where to put it to get the best return, and you don't know because it requires information about what's going to happen in the future, and you don't know what's going to happen in the future. So I think part of becoming a good programmer is getting good at that, sort of figuring out where to spend your time and what's the best way to do it. Okay, so even though I think it's a good thing, it's not always the right thing to do. And another thing is that the way I think about design is that it's for people, even though you'd think it's like for the computer to run stuff. It's really about, the design is like more about helping people use it. So if you're designing a library, then you want to make it simple so that the users can actually save time, and that's a way to be nice to them. So I think it's actually worth doing because it's a way to sort of be kind to others, right? That's one of no, that's what you're doing, is you're actually doing it for people. And it's your coworkers who got to look at your code, or your users if it's a library, right? And so that's one justification, or one, not justification, but motivation for doing it. And then another one is that, and this is really, I think in the heat of battle when we are, we just got to get stuff done, we usually don't have time to make things really elegant. But when you see something that's quite elegant, there's just something nice about it, just in its own sake. And I think I wanted to say that, one of the things that, well, for me anyway, I spent a lot of time programming in Scala, and it's sort of my form of expression. When I was younger, I wanted to be an artist, and that sort of ended up, I'm a Scala programmer. But I try to make things aesthetically pleasing because it makes, I think that's worth doing just in its own sake. Just like art, people don't usually do art for economic reasons, right? And if they were to try that, it wouldn't work out very long, right? So I just wanted to mention that one. And then the last thing I wanted to say about sort of the why is I was interviewing Anders Heilsberg, who designed C#. I went to Microsoft years ago when I was a Java guy. And he mentioned this word simplexity. It's like, what's simplexity? And what he meant by that is you can make things too simple and actually make your users' lives more complicated. And so what I think the goal when you're trying to achieve simplicity in a design, it's not actually to make the design simple, but to simplify the users' lives or the people who are going to be working in it. That's what you want to simplify. Because you can make the design so simple, like if it keeps getting smaller and smaller and more beautiful, it could actually disappear and there's nothing there. That's really simple, but then it doesn't really solve your problem, right? And then in any project or task, there's some inherent complexity of that task. And over time, because computers get more powerful, they have more memory and they're cheaper, then the requirements of the things we're asked to do have grown more and more and more complex. And you really can't get past that. I mean, that's real complexity that you have to actually have in your solution. So what you want to have is make it the minimum amount of complexity in the software that actually does the job it needs to do, and get rid of accidental complexity or extra complexity that isn't really necessary. But I wanted to say about complexity, too, that people actually want it if it solves their problem. I mean, what simplexity really means is that you can make things simple, and if it doesn't solve the problem, people actually want more complexity than that. They actually want it if it's useful. And so part of the art of design is figuring out in between these two things, where's the sweet spot where things are as simple as they can be, but they actually solve people's problems. Okay, so that's what I have to say about simplicity. And so where Scala comes into play is that I think what we do in just programming in general to deal with complicated requirements is make APIs. We actually separate out, we try to put the details, the complex details behind the scenes in front of a simpler API, a simpler interface. So it's application program interface. It's simpler for people, right? So that's the trick, that we just do that all over and over. And that's abstraction. So the reason that interface is simpler than the implementation is because it's more abstract. So we abstract away detail to abstract away complexity. And I think the reason is just because it's for people again. Human brains we can only keep track of so much in our heads at once. So the less I have to think about, the more I can work with it, right? So Scala is really designed to do this. I think if you look at there's a talk that's really great to watch. It's a great video by Guy Steele called Growing a Language. And he starts the talk by just having one-syllable words only in the talk, and he doesn't allow himself to use two-syllable words unless he's defined them in terms of one-syllable words. Then he can use two-syllable words, and the whole talk goes like that. But his idea was kind of like the cathedral and bazaar of programming languages. There's the cathedral way where you design a programming language, and you put in solutions to things people want to do. So like there's in C#, going back to C#, there's link, right? That kind of addresses data access in C#. So there's a nice way to do it. And so they just said, well, C#'s for this domain and this domain and this domain, so let's add these features to help make people's lives simpler. That's a cathedral, right? You actually put the specific things in the language. What I think Scala is like a domain-specific language for library design. So the features that are in Scala are to enable people to make libraries and to solve problems there. So that's more like the bazaar. So anyway, what we do then is we make these things, or we grab them, and then we just write application code. And the application code should just be real simple, because we're just using the simple interfaces in it, and we try to keep that simple. So yeah, so then what the Scala as a growable language is really is I just think that's sort of the point of it, or is that it's like it's designed to make library design simpler, so that you can do this separating out of the detail and allow people to manage complexity and complex requirements. Okay. So I have 10 guidelines, specific guidelines I just wanted to go over. And one of them is there's a lot of features in Scala that are intended for library design. And so one guideline is just don't use that when you're writing application code. And it can be kind of tempting because it's fun to use all these things. They're like knobs to twist. I mean, and none of these things are like that you should never, I'm not saying you should never do it, but just in general, I think that application code in the middle should just be really straightforward. And where you use all those fancy features are in these things when you're designing the libraries. So an example I've seen, for example, would be in application code, you use an implicit class to add a method to something because you like a name better. I mean, it just adds complexity that the person reading the code has to go like, where did that come from? I think it'd be better to just call the method you don't like because it's already named that, right? Now there are giggles because I'm not sure if that means that, oh, I shouldn't have done that. But anyway, so that's one. And another thing I think is that when you're designing, you need to think about the people you're designing for are busy. And they are busy and they don't care about your library because they just want to get their job done. The metaphor that I like for this idea is when I rent a car. I have rented cars lots of times. I have never read the owner's manual. I mean, it's always in the glove compartment. I've never gone in there and read it. I just get in the car, and it takes me a second to kind of figure out where things are. Oh, wait, this is this. And then I can drive off and go to where I'm going, right? When I bought a car, occasionally in my life, I haven't bought many, but occasionally we have bought cars. I did always read the owner's manual when I bought the car, right? But when people use libraries, when they're doing this thing, they don't want to read the manual. They don't want to become an expert in it. They just want to get their job done. They want to just get in and use it, and that's how they're going to be using it. So you have to remember that they're casual and designed for casual use. And then the other thing about in here is teams. People don't usually, interesting software is not usually written by individuals. It's written by teams, so what you are designing is not for people, but for collaborations of people, right? People working together. So that's designed for busy teams. And an example of this from Scala test was that in the old days, when I don't know what version it was, version 1.0, this was in version 1.0, the top thing would do what you think. The second one would not. And I actually documented this in the manual. Which people apparently didn't read because they would keep reporting this as a bug. But I thought that equal should just always mean call double equals, and that B is the one that has these special things. But if you look at it, you'd think it would work. Just by looking at it, you would think it would work. So like if you look at the pedal and you think it's the gas, but it's actually the brake, or you're gonna screw it up. Right? So I actually changed that and made that mean what people thought it meant. And then, it was technically user error, but it was really a fault of the design because people are too busy to read the documentation. Okay, so that's one. And then I think the way to make people work together to collaborate is just to make it obvious. If drop dead stupid obvious what it means when you look at the code, then that saves people time. So that's hard to do sometimes. So if you can't get that, then make it guessable. And that guessable is like you look at the code, or they look at the code, and they think, I'm not sure what that means, but I think it means X, and it does mean that, right? That's guessable. And if you can't get it to be guessable, then make it easy to remember. What that means is they're going to have to look it up. So they won't know what it means. They won't be able to figure it out, but they'll look it up. But if it's easy to remember, then they won't have to look it up once. So that's, I think, for example, one thing that's hard to remember is symbols. If you have a lot of symbols, symbolic names in your library, people can use it. They can look it up, but it's hard for them to remember symbols. It's easier for them to remember names, right? If there's too many of them. So, so here, I actually, this plus or minus, I don't know if anybody remembers that, but in an early Scala test, that's how you did it. And the reason is I just wasn't sure that a symbol was obvious enough. And then over time, I just didn't like it. It was too verbose. And so I went around with some informal surveys, and people could guess it. They weren't sure, but they said, does that mean plus or minus? And I was like, yeah, it means plus or minus. So I changed it to that. Again, I think that making things obvious is the way you get people to work together. They can just read the code and they save some time, right? OK. And then there's two roles people play when they're working with code. One is they're reading code and one is they're writing code. And if you're designing a library, you really want to try to make them equally ecstatic, right? You want to make them happy. And it's just that sometimes these two things are in tension. So what I do when I can't get them to be equally nice for reading and writing is I favor the reader, because I have heard people say, and it seems to be true, but I have absolutely no evidence, that people read code more than they write it. And so I think you should favor the reader. And an example of that from Scala test was this invoke private thing. When I had to come up with a name for that, I had the problem of naming which this room was named after. And I'm kind of curious how hard it was to name the room. It seems like it would be easy. But I had to decide what to name this thing. And what it does is it allows you to invoke a private method, which is a no-no. And even in testing philosophy, people tend to, and I agree, that most of the times you don't want to test private methods. You want to avoid that. But occasionally it's useful, so I made this thing. It uses reflection. And I just had to come up with a name for it. And one of the names I considered was this little lightning bolt operator, which I thought looked pretty, kind of cool, right? And it's like lightning strikes the object and a private method gets invoked. And that kind of, you might be able to figure it out, but I didn't think it was obvious. I didn't think it was guessable. And I didn't think it would be easy to remember because I didn't want people to use this that often. I didn't expect people would, and I didn't really want to encourage it. So I picked A, that's what I used. And the other reason I used that, it's just like it says what it does, but it's kind of verbose to write out. So I sort of favored the reader over the writer here. And if it had been something that I thought would be used a lot, I would have probably come up with a shorter name, but probably still made it a word. But because I didn't expect it to be used a lot, and I kind of wanted to discourage it, I made it spelled out. So that's invoke private. Another one which I think is very central to Scala is, all I want to do is see, there we go, how much time I have left. So one of the other things that I think is very central to Scala is to use the type system to make errors not compile, right? So it saves people because it saves people time, right? It's not just, it also makes things, makes it impossible to get things wrong, but it also saves people time because boom, they get a compiler when they try to do it the wrong way. And so one of the things I did in Scala test early on was I had to think about what should be the default for parallelization of tests when you run tests. Should they run in parallel or not? And tests are usually embarrassingly parallelizable, so it seems like a real simple thing that you'd usually want to run them in parallel. But if they run in parallel by default, then you have to think about concurrent access to shared mutable state. And so people do put that in tests. And it's not the end of the world if you got a concurrency bug in a test, but still, I wanted to make it harder to have that kind of problem. So the default in Scala test is actually all sequential. There's no parallel by default. It's not in SBT. The default in SBT is parallel, and that actually, I think, does make sense for tests. But when you just ask Scala test like a fun suite to run in parallel, what it does is it runs all its tests sequentially. But if you've got 100 suites, then those can run in parallel. So it's parallel at the class level by default, not at the test level, because usually in tests, these things are pretty isolated from each other. Usually, there's a lot of times there's data inside a test class, and multiple tests share that data, and it could be mutable. But it's usually not the case for like multiple ones, right? So that was what the default was. And to actually run tests in parallel, you have to mix in a trait. And that was why. It's just because now you actually have to worry about concurrency. You have to worry about shared access. Yeah, that's kind of concerning, a loud boom. When I walked out of the bar today, the protest was just going down the street. But so hopefully that's okay. But anyway, parallel test execution is also, there's in Scala Test 3.0, there's an async fun suite. And that was tricky because in an async fun suite, there is each test returns a future. And so it can quickly come up with a bunch of futures that can complete later. So I had to figure out what should be the default execution context in an async testing style. And it wasn't obvious. At first I thought, well, I mean, if you're doing things with futures, you'd expect it to run in parallel. And that's what I did to begin with. And then I realized, well, now by default, there's the possibility of getting the concurrency bugs again. And in a test, you're a lot sloppier. You're not as careful. You just put stuff in there. So I felt it was not unlikely people would have that problem. So what I ended up doing in the async style is, by default, there is a default execution context, but it's one that we invented, which just remembers the things to do, so it doesn't actually do them. When you map a future, the execution context that goes in there just sort of puts that job on a queue. And so when a test executes, there could be all these jobs being built up, and then it returns a future. That thread is then used to execute those jobs. So it means that within a test, one thread is doing everything, so you don't actually have to worry about synchronization by default. And then we actually register execution of the second test as a side effect of, or like something that happens when the first test completes, when the future of the first test completes. And the third test is registered to start when the future for the second test completes. So they actually all run in sequentially with one thread, just like in sort of regular styles. And then if you really want them to run in parallel, you can mix in parallel test execution, and then the test will run in parallel. But if you don't change the execution context, they'll still, within one test, everything will happen on one thread. So it's basically the same thing you get with synchronous styles. Okay, so and the other thing I wanted to mention is like the type system. Like that stuff was not really about the type system. That was just trying to make it difficult to screw up. There's a JUnit suite that is a kind of suite. If you're using JUnit, it actually is a JUnit test class, and it's a Scala test suite, so you can run it with either tool. Parallel test execution wouldn't work because JUnit has its own way of doing parallel test execution. So if you try to mix it into a JUnit suite, it won't compile. And the way I did that was I just final override a lifecycle method, and you just get kind of an odd error saying you can't mix this in because parallel test execution tries to override a lifecycle method that's final in JUnit suite. Okay, so one of the things that I think is a human factors thing is the people you are designing for, they actually know something. I mean, they are used to something. And usually when you're designing something new, you want to actually change their behavior in some way. So what this trick is to choose your battles. So actually to sort of fool them into doing things the new way that you think is better by making them feel comfortable. So an example of that I've heard before was the way what James Gosling had in mind when he designed Java. What he thought the industry was doing wrong was they were spending too much time chasing down memory bugs in C. And he thought they should use a garbage collector. But C programmers, and I was one of them, didn't think it would be fast enough, right? So that was what he wanted. He wanted to change people's behavior that way. So what he did is he said Java was a well-orchestrated, he said this at one talk I heard him give, Java is a well-orchestrated fraud because he fooled people into using, C programmers into using a garbage collector by making the rest of Java look like C, right? I mean, the curly braces are the same, and the while loop looks the same, the if looks the same, the for looks the same, but there's no way to free memory. So I think, he was exploiting the familiarity of C programmers with the C programming language to trick them into using a garbage collector. And I think Scala, also Martin Odersky was trying to encourage people to be more functional, right? So he picked his battles, and some of the things he left the same just because that wasn't important to him to change, even though it could be arguably better, like using colon equals instead of equals for assignment, right? Maybe he liked that better, but it wasn't that's one more hurdle that if that isn't really important to what he was trying to achieve, he just leaves that the same, right? So in Scala test, one place I think I did that was, this is what, when I designed, when I first was creating Scala test, this is what people were used to. They were using JUnit or test-ng in Java and writing test methods. And this was the way that I learned anyway, when I first learned about unit testing, was that you make one test method per method under test, right? So if I have a size method, I call my test size method. And if I have a head method, I call it test head method, right? And I had these really long tests because the method did a lot sometimes, right? And I would do a bunch of different things on that. That's how we sort of thought. And then what I thought, what I learned and came to believe is a better approach is to have each test focused on a bit of behavior. So for one method, there may be 20 different behaviors of that method you want to test. You'd actually make 20 different tests. And using a method name for the test name is camel case, and it's painful. So what I did is, in all the styles in Scala test, I made it really easy to write focus tests with descriptive names. But this one was supposed to make people who are used to XUnit comfortable, because it's test, 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 it's flat, it's just like JUnit, but it has that one change, which is it encourages focused tests, focus on one bit of behavior with a descriptive name. So anyway, that's exploiting familiarity. Minimizing redundancy is, I think, another way to keep things simple is to not give people too much choice. I really like this thing from the Zen of Python. We have the SIP process in Scala, right? And the SLIP process. SIP is for improvements to the language. SLIP is for improvements to the library. That's called PEP in Python. The PEP is like a SIP. And they have one that's just philosophy. So I think that's kind of a neat idea. I don't know that we would ever be able to agree on a philosophy for Scala in our community, but there's one thing in there that I think is really nice. There should be one, and preferably only one, obvious way to do that, and that's how they hyphenated it. So I copied that. I think that's a good thing, right? And I'm the guy that has 52 style traits, right? So what I would like to ask you, to try to see if you believe me, is this is a picture of my screwdrivers, and the reason there's so few is that we had some work done on our house a few years ago. I think it was 5-6 years ago, and my toolbox disappeared, and I had no tools. I had 0 tools. I'm sure it was an accident, but someone thought they were their tools, and they took them. So I decided I would just buy a tool. I wouldn't go we love doing this, buy a big thing of tools. I'm just going to buy a tool when I need it, and just grow a toolbox over time with things that I actually need. And at the time I took this picture, which was a few years ago, this is how many, this is the entire, this is all my screwdrivers. I had five of them. 1, 2, 3, 4, 5, 6 of them. So far, that's all I needed. So would my toolbox be simpler if I just had one screwdriver? In a way it would, because it would make it easier to choose which screwdriver, right? It would make that simpler. But then if it was the wrong size, it makes my life more complicated, right? So I think that kind of complexity or redundancy, when each one is focused on a different task, is actually makes users' lives simpler. What you want to avoid is this kind, where really you just have a bunch of different things, and it's like, well, whatever you feel like, you know. And so I've tried to keep that out of Scala tests, and it has snuck in, and I've tried to deprecate it out sometimes. I, for example, felt that should and must were, you know, in retrospect, maybe I just should have picked one. So I did deprecate that one time, and we had a user revolt. It turned out that some people really want a purple handle, and so you got to leave it in there. So once you have to be careful. Another guideline should be careful what you put in, because it can be really hard to take it out. But anyway, with the style traits, I did feel like I came to feel there was maybe just one or two too many. I wish I could take some out. And I was talking to Jonas Bonner, who the Akka guy, the guy who designed Akka, one time, and I was telling him about this. It's like, you know, I wish I'd kind of like to take one out or something. And I said, he asked me which one. I said, well, probably flat spec. And the reason is because all the other ones were modeled after something. Like Fun Suite was like XUnit. Fun spec is like R spec, right? Word spec is like Specs 2. So there was sort of, everyone was kind of inspired by something. There's Cucumber is a very popular tool, and we have feature spec, right? But flat spec I invented. It was not like anything else. So I said, you know, that was probably the one I should have just left it out, you know. And he goes, oh, flat spec, but that's so nice. That's my favorite one. And I was like, oh, great, I can't get rid of flat spec. So we're stuck with them all. But I'm trying really hard not to add anymore. And I did think they were, you know, focused on specific things. If you're coming from here, I want you to be comfortable. If you're coming from there, I want you to be comfortable. But what I found was that, you know, when you look at screwdrivers, people can figure out what they're for by looking at them. When you look at like Fun Suite, Fun Spec, people have no idea what those differences are. So what I realized is I needed to add guidance of like, this one's for this use case, this one's for that use case. So that's what I did eventually. So this one is Fun Suite. It's people coming from XUnit feel comfortable and familiar, right? But you can write descriptive test names and focus tests. So, okay, so that's minimize redundancy. Maximize consistency is just another kind of simplicity, because it's one less thing for people to, like inconsistency is another thing for you to keep in your head. And the example I give here is this one, which I think, I'm not sure if Adrian's still here, but I think they're going to get rid of in 2.13, which is that by default, when you just say set in a Scala program, it means immutable set. When you just say map in a Scala program, it means immutable map. Which you say seek, it means general seek. That could be either mutable or immutable. So I have release code thinking I was like immutable index seek, and it actually wasn't general, which is not the end of the world. But it's just a very easy mistake to make, because it looks like it would be immutable seek, right? So that's consistency. And then there's this one. I'm not sure why I put this near the end, but I think that this is one of the really tempting knobs to twist, is to make symbols. And the guideline I think is good to keep in mind for like deciding whether or not to use a symbol is, if your users are already experts in that symbol, then you should use a symbol. But otherwise, maybe you should pick a word. And the reason is because if they're just kind of, it's hard to come up with, if they're not an expert, they're going to have to learn it. They're going to have to look it up and learn it. And it's just hard to keep those things in your head for some reason. Keep many of them in your head. And the example that I would like to show here is these are both valid Scala code using big integer, but the top one is using Java lang big integer. And the bottom one is using Scala something math big integer, or Java math big integer and Scala math big integer. So I think, you know, this symbol one is a lot easier to read, and especially you get a large expression, it looks like math to me. But I think the reason that it's better than using words is because I'm already an expert in star and plus. I know it means star and mean plus. I know what what it means. So if you are doing a library internally for scientists who are always in some domain where the papers that they're reading have all these little squiggly things, if you use symbols, they'll be like, oh yeah, I know what that means, and it actually will make it better for them. So you should use symbols if they're experts in them. But otherwise, I think it's better to use a word and just use a word. What sometimes people will say is that, well, you know what, the best thing to do is give people a choice. You know, if my symbol is non-obvious, like frowny face here, I'll just give you another option, which is fold left, which means the same thing, an alias. And I'm one of the few people I've met who, so I'm kind of swimming upstream here, but I don't agree with that, because it gives the writer a choice, doesn't give the reader a choice. So I think really you should pick one or the other. And it's also a kind of redundancy, right? There's two ways to do it. So just pick one way, and the way you decide is that symbol obvious to their users and they're already experts in it? And if it's not obvious, is it guessable, like plus minus? Okay. Easy to remember is another one. I mean, it's basically, it's not like you should never use them, but just decide if it's the right thing to do, then just use that. Otherwise, just use a word. Okay, so that's symbols. And then lastly, this kind of goes back to number 1, which is try not to use library features for application code. Just keep that just silly, simple. Create objects, invoke methods on them, look at the answer, right? In general, there's all these features in Scala that are really allow library designers to do amazing things and just make really great libraries for people to use. But you want to achieve that with a minimum amount of those features, because like what I think the trade-off is that this client code is really clear for the domain that it is, whatever the domain is. But how it works is not necessarily always so simple. And sometimes people need to know how it works. So I think that keeping the magic down is very important. And Dick Wall tells a story of when he was a kid. He went into the garage one time, and his dad was using a new power tool. It's back to tools again. It's like a zzz, one of these drills that power drill. And Dick, of course, wanted to use this new toy. And his dad said, well, here, why don't you use this hand drill first? And it's like, well, I want to use that thing. And what his dad said is that remember what tools are for. They're for solving problems, not finding problems to solve. So I think that's a good way to think about Scala's feature set is don't just use them because they're fun, even though it is fun. Try to avoid that temptation and just use the minimum set of features necessary to solve the problem. Okay, that is all I have to say about simplicity. And I'm sorry it was a little more complicated than I'd hoped. But does anybody have any comments or questions? Yes?
Just wanted to double check about another Python mantra.
Uh-huh.
Explicit is better than implicit.
That's interesting. So I don't know, I'll repeat it since he didn't get the microphone. There's another Python mantra that explicit is better than implicit. I think it's in that same PEP, yeah. I don't think so. I think we actually, I think we have a different philosophy, which is, so the trade-off with implicit is, what implicits in Scala can do is it can simplify, it can drop boilerplate, it just falls away like rose petals, and all that's left is the essence of the meaning, and it's beautiful when that happens, right? But then what can also happen is, an example of this was using my first time using spray. This guy sitting next to me in the cubicle that I was working with, he said, "Can you explain how this is happening?" And I could not. I couldn't figure it out because there was a magnet pattern and there was implicits, and I couldn't find it. Right. So when it's not explicit, it can be very obscure. So we have to balance that. But I don't. In Python, they did have a different philosophy, which always makes it explicit. Somehow they kept it simple. Anybody else? And I like Python, but I like Scala better. But I think it's nicely done. Okay, that's cool. Let's hope those booms were a good thing. Celebration. All right, thank you.